Okay, we are on the next video. So we have another sketch the graph, and I'm actually going to move through this quickly. So again, if you're confused, you can completely and utterly be like, Mr. David, you need slow down. So I'm going to turn this into standard form to find the vertex. But I am actually going to use this to find the x-intercept. So this form is going to be useful to find the x-intercept, okay? But it's not useful for third round. So we're actually going to speed run this. Okay, I'm going to separate this out so we get x squared minus x squared plus 6x. Okay, so that's by itself. Now, if you notice, there's a negative here, which I am going to have to take out. And as I remove it, I'm going to change this positive 6x into negative 6x. As I do that, though, I can also complete the square. So completing the square, divide negative 6 by 2, you get negative 3. Negative 3 squared is going to be positive 9. But I still have to multiply it by negative 1. So positive 9 times negative 1 is negative 9. However, if I added negative 9, then I have to do the opposite here, which is plus 9. Okay, so I subtracted 9. I have to also add it to be equal. It has to stay equivalent. Okay, if this is a completed square, then I can change it into the form x minus 3 squared. Okay, this on the outside becomes plus 1. Okay, now we have our vertex. What's our vertex, people? Vertex is 3, because remember it was a x minus h squared plus k. So this means it's 3, and this means it's 1, so our vertex is 3, 1. Now what about x-int? What about our x-intercepts? Our x-intercepts are actually affected by this starting equation. So what we do is we set 0 equals to negative x squared plus 6x minus 8, and I have a preference on how I solve this. You do not have to do it this way. I like taking out the negative because it's just easier. Okay, and then you factor this. What goes into 8 and subtracts into 6? Well, that's x minus 4, x minus 2. And this equals 0, so x equals 4, and x equals 2. Now, does that make sense with this? Yes, because our a is a negative. If a is less than 0, we have a downward slope. Okay, downward u, kind of like a mountain. Okay, sorry if I went through this one quickly. It is in the book. It does explain it more carefully. It doesn't speed run it. So if you want to know what page it is on page 129. Okay. Actually, not 129. Sorry, 130. Apologies. You're going to look at 130, 129 and be like, Mr. David, I don't find it. It's on 130. They do go slow through it. They do exactly what I do, so you can double check, okay? Okay, thanks, guys. I'm going to go to the next problem. Okay, sketch the graph. So the sketch the graph is actually, you could just use these x-intercepts and the vertex to sketch the graph. Plot those 2 points, plot the the vertex, and then draw the problem. If you're curious on how I would do this, I'll do it right here. It's an even smaller graph. All my graphs have gotten smaller progressively. Maybe that shows you something about my state of being. Maybe it doesn't. Okay, so I have our vertex, okay, and axis of symmetry just going down, and x-intercept is 2, and x-intercept is 4, so I have this right here. Okay, now if I wanted to plot one more point, I would plot right here, and right here, so just keep going. Because its slope is the same as the parent function, therefore all 5 original points are going to be pretty easy to predict. If you have a question about that, you can ask me. Yeah, that's how you erase. You have to make that sound. Okay, Write the standard form of the equation of parabola whose vertex is 1, 2 and passes through the point 3, -6. So remember, our standard form is f of x equals a x minus h squared plus k. What did they give us? Vertex. Vertex is h and k. So they did not give us a. So x minus 1 squared plus 2. Now, if they give us the point, 3, -6, that allows us to solve for this. How does that allow us to solve for this? Well, what we're gonna do, sorry, let me put our points. Vertex is 1, 2. I'm gonna plug in 3, -6. So I'm gonna plug -6 for here. -6 equals a. Then I'm gonna plug in 3 for x squared plus 2. What are we going to do? 3 minus 2. 3 minus 1 is 2. 2 squared is 4. So we get -6 equals 4a plus 2. Subtract the 2, we get -8 equals 4a. Divide by 4, we get -2 equals a. So what's our standard equation? F of x equals -2 x minus 1 squared plus 2. There's our standard form. Okay? So simply put, if we have passes through right here, we just plug it in. Vertex, we plug it in. Okay? Okay? That is how you do that problem. We're on 6 minutes and 41 seconds, and I gotta talk about maximum and minimum. Okay, it's actually pretty straightforward. Maximum. Okay, or it says minimum first. So if a is larger than 0, so if a is larger than 0, our function f has a minimum. If you're wondering, did I have to read it or read my work at the top to remember how to spell minimum? The answer is, of course, yes. So our minimum is when x equals -b over 2a, or rather, the minimum value is our vertex. And what is our vertex in our regular form? It'd be the minimum value would be f of -b over 2a. That's not WA, that's supposed to be a 2a. I don't know where my finger was. 2a. It was over W, obviously. Okay? And if that's the same thing, you know it's beautiful. This is a beautiful thing about computers. You can go like this. Control V. So instead of being greater, if a is less than, then we're going to have a maximum at this, and our maximum so they want us to consider, not bold this, consider the function f of x equals ax squared plus bx plus c with vertex -b over 2a and f of -b over 2a. There we go. That's a vertex. This is our maximum and minimum. And look at that. That's, boy, we are cynical. So minimum is when you have a U shape. Parabola is a U. When it's a maximum, parabola equals, you know, it's funny, I'm going to use a math symbol because I'm lazy, is this symbol. Oh, that is beautiful. Okay? So, look at that. So, minimum, the parabola looks like U. maximum, it probably looks like this. Here, let's zoom in so you guys can see this beautiful thing. I'm so proud of myself. You should be proud of me too. Look at that. Oh, beautiful. Oh, I just flew. Okay. We'll see you guys in class. Bye.